now we will consider an AC driven capacitor. So again, we have our little AC supply right across the capacitor C, and the little oscillating voltage is delta V max sine omega t. Okay, well, the delta V we're applying across the capacitor, we know has to be equal to the charge on the capacitor over its capacitance. So we can start plugging in things. Let's solve for the charge. So Q, the charge on the plates that can vary in time, is now C times delta V max times sine omega t. And in circuits, we usually care about current, not about charge. So if we wanted the current in the circuit, we'd take the derivative of this. So I, the current as it varies in time, is dq dt. So the derivative of sine is cosine. You pull out an omega, you have C omega delta V max, cosine omega t. So we apply a voltage, we get a current. We can look at them, we see they're both sinusoids, but there is a phase difference between them. So if we plot now time, and here I'm going to plot two things. First, I'm going to plot the sine, or I'm going to plot the voltage. We're driving with a sinusoid, so if we call this the origin 0, a sinusoid we know starts at 0 and does something like that. So this is delta V there. And then the current we derived is a cosine. So we know it starts high and goes low. So it's going to start up here, and it's going to hit 0 when that is the maximum, and minimum when that is 0, and 0 when that's there, and this when it's there, like that. Where this is I. So since one is sine and one is cosine, they're out of phase by 90 degrees. And here we get that the current leads the voltage when you have a voltage-driven capacitor. And by that mean, if we were to watch time go this way, the current has already peaked and coming down, and then the voltage is just starting to peak. And the current has already gotten back to 0, and a little bit later the voltage gets to 0. So sometimes it's confusing looking at those graphs, who's leading whom. But in this case, the current leads the voltage for a capacitor circuit. And the voltage you apply and the current you get are out of phase. And that's different from the resistor. When you just drive a resistor, current, voltage are together. They get out of phase when you start using other elements.